Hello, in this video, we demonstrate the memory read-write operations. As we said in another video, the memory unit consists of number of units to store information, and if the memory size is 2 to the power k words and it has n bits per word, it will have a k bits address line and n bits data input lines, n bits data output lines, and two control lines that we use for read and write. Now, to transfer a new word in order to be stored into the memory, we do the following steps. Number one, we apply the binary address of the word to the address lines. So we put at the address lines here the address of the word that we want to store or to save. And then number two, we apply the data bits that must be stored in the memory to the data input lines. So this will be the first thing that we do, and this will be the second thing that we do, and the third thing, we activate the write input. So we make the write active. And then the word will be stored in the memory after some time, as we will explain next. To transfer a stored word out of the memory, which means to read a word from the memory, we do the following. One, we apply the binary address of the word to the address lines. So this will be the first step to do. And second, we activate the read input. So read will be activated. And then after some time again, the data output lines will have the data stored in the memory. Usually, we have a table to describe the read-write operations, and in a practical memory, we have two alternatives. Either we have read and write lines to the memory, or as a substitute, usually we have one line which is enable and the other line is called read or write. And actually this alternative is more commonly used in real memories because chips always need to be enabled. Therefore, if we have these control inputs now, memory enable and read write, if the memory enable is 0, we don't care what is the read write and no operation will be done. Nothing will be done because simply memory is not enabled. So we will be neither able to read nor to write into the memory. However, when the memory enable is 1, then an operation will be performed depending upon the value of read write. If it is 1, then we will read a word from the memory whose address is the address line. So we read the selected word. And when the read write is 0, we usually write a word into the memory in the address that is on the address lines. And because this is read write, usually we call it read write bar, because if it is 1, it is read, and it is 0, it is write, and that's why we have the bar here, read write bar or read write prime. That will be easier to understand. Now, the memory write operation, as we said earlier, there are 3 steps that are done. Number 1, we put the address here, and number 2, we provide the data here, and number 3, we do the memory enable and read write. So it must be enabled and the write will be on. So this is a timing diagram, as a matter of fact, that shows the following. When we have the data available and the address available here, so we make the memory address at the input of the memory and the data available at the input of the memory, and we enable the memory, so the memory is enabled here, and read write is 0, which means we will write. Now, after this, we will wait actually some time until the word is written into the memory. How long do we need? We need approximately until here. So if the clock cycle is 20 nanoseconds, as an example, we usually wait 20 plus 20 plus 10. So wait approximately 50 nanoseconds in order to be able to write into the memory. So at this point here in time, the data will be latched into the memory, which means the memory will store the information after this time. So the memory enable switches to the high level and the read write to the low level. This is the step here to enable the memory, and the two control signals must be active for at least 50 nanoseconds, which is 2.5 clock cycles. And of course, the address must remain valid all this time, and the data must remain valid all this time in order to be able to write into the memory. Similar thing to the memory read operation now. To be able to read from the memory, again, the first thing we do is to put the memory address at the address lines. So here the address is valid at this point here. And then step number 2, we enable the memory and we make the read write active, which is 1. So memory is enabled at this here in order to initiate the read, and read write is 1, logic 1 here. And the address must be valid again for at least 2.5 clock cycles, which is 50 nanoseconds, like this here. And also the memory enable here and the read write must be active for again 50 nanoseconds or 2.5 clock cycles, and the data will be valid only at this time. So if we want to read after we put the memory address and we enable the memory and the read write, the data is not available at the outputs immediately. It will be available after approximately 2.5 clock cycles, as we can see here. Now we look at memory types. Integrated circuit RAMs are available in two possible operating modes, because memory unit usually we can buy it as an integrated circuit, so which has number of memory words as specified in the document of the sheet of the memory. There are two types of operation. One is called static RAM and the other is called dynamic RAM. The static RAM, it consists of internal latches that store the binary information, and it's called static because the stored information remains valid as long as the power is applied to the unit. If we disconnect the power from the unit, the information will go, it will not stay. However, the dynamic RAM, on the other hand, it stores the binary information in the form of electric charges on capacitors provided by the MOS transistors, which is metal oxide semiconductor transistors. And when we store electric charges, the charge on the capacitor tends to decay with time, and therefore the capacitors must be periodically recharged or by refreshing of the dynamic memory every few milliseconds. So this is different actually from this one. The static RAM is easier to fabricate and has shorter read and write cycles. However, the other one, the dynamic RAM, offers reduced power consumption, which is very, very important for the chips, and it allows larger integration of units on the chip. Therefore, the DRAM is much more commonly used than the static RAM.